So now let's talk about Spark SQL and the Spark 2.0 way of doing things using data frames and data sets. So the thing about the direction Spark is going in is that it's dealing more and more with structured data. So when we're dealing with RDDs, they're just these RDDs of rows of stuff, right? It doesn't really have any information built in about what the types are of that stuff explicitly. So what data frames do in Spark is extend the RDD to a data frame object. And a data frame just contains row objects where those rows can contain structured data. So, now you can have actual structured information in a data frame that has actual columns of a given type and given names. And once you have that, you can actually run SQL queries on your data frame within Spark. So again, we're kind of blurring the lines here between the different technologies on top of Hadoop. They all tend to seem to converge on SQL at the end of the day, don't they? And the good thing about this approach is that since we have an actual schema associated with a data frame, we know what the actual types are within it. We can store that more efficiently. We can transport it across the network more efficiently. And we can also optimize those SQL queries to make Spark even faster and even more efficient. And it also means we can read and write to structured data formats such as JSON or Hive databases or Parquet files, whatever you have. And we can communicate with other databases using JDBC or even systems like Tableau. That gives you sort of a higher level view of your data. Now within Python, it's pretty easy to use. The lines, again, are kind of blurry because in Python, everything's dynamically typed anyway. So all this talk about typed and structured data doesn't really mesh very well with Python all the time. But using it's very simple. Basically, you can just import SQL context and row into your script. And at that point, there's several different ways of creating a data frame object. If you are connecting to a Hive database, you can just create a Hive context and read in a data frame from that. Or more commonly, you'll actually read in data from a file somewhere. That might be something on your HDFS file system. You can just say spark.read.json, given a Spark object, and create an input data frame where it just uses the contents of the JSON file and the structure that's inherent in it to infer the column names and column types of that data. And once you have a data frame, you can call create or replace temp view to actually create what looks like a little database table. And we're going to call that table my structured stuff in this example. So once you have that, you can actually issue SQL queries on my structured stuff. And here's an example, for example, of running a SQL query on a Hive context that we imported. And you could do the same thing with any data frame, just call .sql and actually execute SQL commands on your data frame. You can also do things more explicitly. So instead of actually writing SQL, you can do things more programmatically. You can do things like .select if you want to select a given column, filter to actually apply some function that you will filter your data frame by, group by, just like group by in SQL, it will give you back the results grouped by whatever field you want, very much like a reduce operation, right? And you can also do things like .mean to actually compute the average of all those grouped results. That might come in handy. That would be a very quick way of doing what we just did in the previous example, right? Of finding the average ratings of all the movies in our data set. We'll come back to that. And you can also, remember, data frames are built on top of RDDs, so you can always extract the underlying RDD if you want to, and perform operations at the RDD level as well. So if I wanted to, I could call RDD to get back the RDD of that data frame that contains row objects and apply some function to those row objects if I want to go down deep to the RDD level. Now in Spark 2.0, they introduced a new concept called a data set as opposed to a data frame. The lines between the two are very blurry in Python because Python's all dynamically typed. But what you need to know is that a data frame is really a data set of row objects. And data set is a more general term that can contain any sort of typed information, not necessarily a row like you have in a data frame. So again, this is just a way for Spark to actually get more information up front about the structure of your data, and it can do that to actually, for example, give you more compile time errors about problems instead of waiting until runtime. That's kind of the real power of data sets. And it also encourages you to use SQL queries within your scripts that actually allow further optimizations. Again, with Python, it doesn't really mean you have to do anything differently necessarily, but in Scala and Java, that's more of a big deal. Okay. A little footnote here. You can actually start a database server using Spark SQL and connect to it and query it just like you would any other database. Kind of a neat trick. So if you start the thrift server built into Spark, you can actually connect to it through JDBC or ODBC and just start issuing SQL commands on a given table that you've actually loaded up. So kind of a cool thing. Also, Spark SQL is very extensible. You can actually create user-defined functions that plug into SQL and create your own functions that you can use within your SQL queries. Here's a simple example of creating a function called square that squares a given value and actually using that within a query. So very easy to do that as well. So that is the power of data frames and data sets in Spark 2.0 and Spark SQL. Another thing that's worth noting is that this is sort of the unified API between the different subsystems of Spark going forward. So you'll see that in Spark 2, the MLlib, machine learning library, or the Spark streaming library, are all now have dataset-based APIs that you can use. So datasets are kind of the common denominator between these different systems that allow you to pass data between them. So not only do you get performance benefits by using datasets in Spark 2, you also get easier ways of actually using all these other capabilities built on top of Spark, where you can mix and match them in interesting ways. But with that, let's look at a real example. Enough talk, let's get some action. Let's revisit our example of looking at the worst movies, and this time see how we might do it using Spark 2 and data frames.